Hello, in today's lesson, we are going to learn to create our own line plot. In the past, we've been given a line plot that we had to analyze, but today we are only given a table of data, which actually comes from the previous problem, the experiment of collecting water samples from three sources of fabric. Now, again, the line plot is nothing more than a number line. Well, it's a little bit more than a number line. So we do have a number line. So let's start by that. That goes on forever, right? Just like any number line. However, we are plotting some values. We're plotting some values. Now, which values are we going to plot on our number line? Well, let's identify. We are talking about, again, we are talking about nylon. Let's label it in red. And we do have, I believe, 8 measures, right? 1, 2, 3, 4, 5, 6, 7, 8. Altogether, 8 by 3, 24 points, right? And then we have polyester. So let's label it in blue. We have polyester, right? So we can have polyester. That would be our syllabus. Not syllabus, like it's called labels. So this is our nylon. Nylon dots will be in red and polyester dots will be in blue. And how about we make black dots, right? This is our cotton values, and we're going to make black dots, right? Black dots for cotton values. So our job is to plot 24 data points on this number line. Where do we start? We have to start with an organized list. Here is what I recommend. I recommend that we first plot one fabric, one row at a time, right? So let's take polyester. Let's take polyester. Step 1, let's identify the smallest value. So let's again, we have 1/8, 1/4, 1/8, 1/4, 3/8, 1/4, 1/4, 1/8. We have nothing more. Then we have nothing more than between 0 and 8. So let's just place right here. Let's just place some numbers, right? We're going to have 0, and then we're going to have a 1, maybe a 1. And maybe we're going to have a 2, 1 and 2. And somewhere here we will have a 3. And let's break them up into 8 equal parts. So this is 2 parts, this is quarters, and each quarter becomes an eighth. Again, so these are the major ones, right? 0, 1, 2, and 3. And each of them we have to break up into halves, then each half into quarters, and each quarter into eighths, and again into halves, each into quarters, and now we have eighths. So let's scan our polyester values. We have nothing that's more than 1. This is how much water polyester fabric retained because Jake squeezed the fabrics, right? So look, he gets 1/8 of a cup, 1/4, 1/8, very little quantities. So let's plot polyester. Here is your 1/8. Right? We can do dots, we can do axes. You will see different representations. We can do little axes, they're easy to count. Then we can have 1/4, and we're going left to right, just like that. We're going to go left to right. So we did 1/4, X it out. We did 1/8, X it out. We did another 1/8. Cancel it out, cancel it, because this way you will go organized. Another quarter, okay, or 2/8 right here, and 3/8. Here's another one, did that, another 1/4. Okay, did that, another 1/4, did that, and so sorry. Okay, so 1/4 is right here, and 1/4 is right here, 1/4, 1/4, and finally 1/8, right? So we're done. We are done with polyester. We can kind of erase that and erase that. Now let's consider the next type of fabric, and that is of course nylon. And again, we're going to go left to right, plotting the values. What do we have here? We have 1/2. Okay, 1/2 is 4/4. Here it is, 1, 2, 3. This is our 1/2 for polyester. X it out. 1 and 1/8. Ooh, we're now more than 1. Yes, nylon retains more water. Then we have 5/8. So here we go, not 4/8, but 5. X that number out. We have a 1. Okay, so let's place an X for 1. Finish that value. Another 5/8 is right here. Finish that value. 3/4, which is 6/8. Okay, finish that value. 7/8, we plotted that value, and another 3/4, which is 6/8. So here is where we finished 8 values. We can compare. Do we have 8 value points, data points for nylon? Yes, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now let's finish with nylon and let's pick up another color. I do like black in this case. I do like black for cotton. Now look how much water Jake was able to squeeze out of his cotton samples made out of cotton. Look at that. First, 2 cups. It's in cups. You see, it's in cups. So here's our 2 cups. Let's place a fat X. X it out. 2 3/8 right here. Here is 2 3/8. 2.5, which is 4/8 right here. 2 3/4, which is 4, 5, 6. This is 6/8. 1 3/4. Okay, we're getting 1 3/4, which is 6/8. 1, 2, 3, 4, 5, 6 right here. 1 3/4, X it out. Oh, 2 1/4 right here. 2 1/4 right here. 1 7/8. We are here. X it out. And 2.5, which is 2 4/8. We are right here. Done. Done. Look, the fabric that retained the most water are all the black data points, which represent the cotton fabric. Let's go answer some questions. Make a line plot of the results. Include title and labels. So we got the labels. And what would be our title? We can say water squeezed out in cups, just like the title of the table. Water squeezed out, and we're using cups, right? So it's between 0, 1, 2, or 3 cups. Did that. Which fabric absorbs the most water? Of course, it's cotton. Look at how much water, cotton absorbed right here. Look at this. This is all absorption of cotton fabric, right? In gray. Which one absorbs the least? Well, look, what's on the opposite last, right? Least quantities, and that's of course polyester. I'm even using the same color schemes right here. Polyester, right? It's all the way on the left of the number line. Find the difference between the highest and lowest data for each fabric. Well, we can use the data, the table, or we can use the number plot. So we have each fabric. So we have polyester, we have nylon, and let's use black for cotton. Let's build a table. So, and we're gonna have the minimum value and maximum value, and then we can find the difference, right? So let's go. For polyester, the smallest quantity is 1/8, and the largest quantity is actually only 3/8, 3/8. So the difference is 3/8 and 1/8 is 2/8 or 1/4, right? That's the difference. Now for nylon, I'm going to pick up a red color. For nylon, right? For nylon, the smallest quantity is, that's in red, it is 1/2, right? 1/2 is the smallest quantity. 1/2. And what is the largest? It's 1 1/8. 1 1/8. So how do we subtract 1 1/8 minus 1/2? Well, 1/2 is actually 4/8. So we can have 1 1/8, which is the same as 9/8 minus 4/8, and the difference is 5/8. So the difference is 5/8. And finally, for cotton fabric, what is the smallest? The smallest is 1 6/8. We can put 1 6/8, right? Or 1 3/4. 1 6/8. And the largest is 2 and also 2 3/4 right here. This is your largest quantity, 2 6/8. So the difference in cotton is quite large. You see the data points are more spread out. It's 1 cup. Now find the average for each type of fabric. Now I hope you friends remember that in order to find the average, we first find the sum, and then divide it by 8. Okay, so I will allow you to do this math by yourself because we just finished the unit on